All right, we're going to start with page 1 of the review by simplifying radicals. So we're going to start with, let me turn my volume up, square root of 32. So the square root of 32 is the same thing as square root of 8, or excuse me, the square root of 16 times the square root of 2. You could have started with 8 and 4, but you'd have to break that down further. We know the square root of 16 is 4. We don't know the square root of 2, so our final answer is 4 square root of 2. Remember when we're doing these for like 50, we want to look for numbers like 4, 9, 16, 25. So the square root of 50 works out perfectly with 25, so it's the square root of 25 times square root of 2. Again, we know the square root of 25 is 5, so we're down to 5 square root of 2. When we're adding these, we just need to make sure that the thing on the inside of the square root of the radical is the same. And it's just like we add like terms. So 3 and 7 gives me 10. And you don't do anything with the square root of 2, it just stays the same because it's like you're combining like terms. When I multiply, it's a little different story. I multiply the outside numbers together. So 6 and 2 is 12. And then I multiply the inside numbers together and they stay in the square root. So it's 12 square root of 15. This one's actually kind of a trick one because it's really easy actually. A square and a square root cancel each other out, so it's 14. This one is like one of those where we can't leave our answers, so we have to get rid of the square root on the bottom. It's called rationalizing the denominator. So I multiply by the square root of 5 on top and bottom, and I get 9 square root of 5 on top. And on the bottom, the square root of 5 times the square root of 5 is really the square root of 25, which ends up being 5. So my final answer is 9 square root of 5 over 5. This one you can either distribute the squared to both parts, or I just tend to write it twice because squared really means you're multiplying it by itself twice. So basically cross out the square and say I'm just going to write it twice. And then I do the same as I did above in D. So I multiply the outside numbers, which is 16, and the inside numbers, which gives you the square root of 25. We can't leave it like that because we know the square root of 25, so 16 times 5 gives me, let's check, 1 second, 16 times 5 gives me 80. When I'm subtracting, it's the same as I'm adding, so I need to make sure first that it's the same thing inside the square root, and it is, so then I just do the outside numbers, so 15 minus 7 is 8, square root of 6, and that cannot be simplified. And then the last one, I multiply the outside numbers to get 18, I multiply the inside numbers to get the square root of 10, and the square root of 10 cannot be simplified, so I'm done. Now I'm going to determine if triangles are right, acute, or obtuse. So to be right, it's going to be a squared plus b squared equals c squared. That means it's a right triangle. If a squared plus b squared is less than c squared, that means it's an obtuse triangle. And if a squared plus b squared is greater than c squared, that means it's an acute triangle. So I'm going to start with this first one, and I typed 2 square root of 3 in my calculator, and I know that it's approximately 3.5, which means that 4 has to be my hypotenuse. So I'm going to set it up as 2 squared plus 2 square root of 3 squared equals 4 squared. 2 squared is 4. I know 4 squared is 16, so the only thing I have to worry about here is the 2 square root of, I'm just going to move this down, is the 2 square root of 3. So I'm just going to kind of do it off to the side here. 2 square root of 3 squared is really the same thing as 2 square root of 3 times 2 square root of 3. Again, I multiply the outside numbers, which is 4, and the inside numbers, which is the square root of 9, which is really 3. So I get 12. So it's 4 plus 12 equals 16. If they're equal, remember it is a right triangle. Okay. Right, moving on to the second one. I have 50 squared plus square root of 14 squared equals 51 squared. 50 squared is, I think, 2,500. Oopsie, wrong number. Yep. 14 squared, the square and the square root cancel each other out, so I just end up with 14. And then 51 squared is 2601. So 2,500 plus 14 is 2,514, and that is less than or smaller than 2601. So I looked on my cheat sheet here and see that that must be an obtuse triangle. Right, and the last one, I'm going to set it up as 50 squared plus 3 squared equals 51 squared. 51 squared is 2500 plus 9 equals 2601, and the same as last one. It's less than 2601, so it is also an obtuse triangle. So again, you just kind of need to remember these things right down here, if I can make it nice and circle. Right, now we're going to move on to just some basic Pythagorean theorem problems. Oops, I repeated my slide, that's all right. So some of you are going to try to make these into specials. Remember, the special triangles are only a small portion of your test. You are just going to be using straight a squared plus b squared equals c squared for a lot of triangles, okay? So I'm going to call this side a. You could have called it b, you could have called it x, it doesn't matter. So it's a squared plus 12 squared equals 15 squared. And I know that 15 is my hypotenuse because it's across from the right angle. So I get a squared plus 144 equals 225. So a squared equals 81. When I take the square root, I get a to equal 9. So this side length right here is 9. Right, I'm going to call this one b just for the fun of it. So again, I know 7 is my hypotenuse because it's across from the right triangle. So it's going to be 4 squared plus b squared equals 7 squared. So 16 plus b squared equals 49. B squared equals 49 minus 16, which is 33. Square root. B equals the square root of 33. And you could get that to a decimal if you want, because this cannot be simplified. But I'm just going to leave it as the square root of 33. So we'll call our last answer too. Right, and the last one, we're going to call this, I'll just call it a again. So I have a squared plus the square root of 35 squared equals 4 square root of 7 squared. So a squared stays. The square and the square root on this one cancel each other out, so I'm just left with 35. And I'm going to do that one off to the side. So 4 square root of 7 squared is just 4 square root of 7 times 4 square root of 7. So 4 times 4 is 16. Square root of 7 times square root of 7 is the square root of 49, which is really 7. So then I just multiply, and I get that to be 112. So to finish solving, I get a squared equals 112 minus 35, which gives me 77. Square root, a equals the square root of 77. And again, that one can't be simplified either because it's 7 and 11, both of which are not perfect squares. Okay? All right, and now we're going to move on to number 4. This is the end of the first page after this, so you'll have to move on to the next video. So number 4 is specials, because they give us this 45-degree angle. So I always want you to remember your little shortcut. For 45, 45, 90 is x, x, x square root of 2, which really means that my two sides are equal. They're in isosceles. And then to get the hypotenuse, I times by the square root of 2. So I know one side, which means the other side is congruent because I have an isosceles triangle. And to get the hypotenuse, I just times by the square root of 2. So 6 square root of 2 is my final answer. So x is 6 square root of 2, and y is 6. Second one here is another 45, 45, except in this case I know the hypotenuse. So normally I times by the square root of 2. This time I'm going to divide. They cancel out, so each of these sides must have been 7 in order to get the hypotenuse to be 7 square root of 2. And then my last one is a 45, 40, or 30, 60, 90, and I want you to remember that shortcut. Short leg is what we call x. To get the hypotenuse, it's easy, you times by 2. And to get the long leg, you times by the square root of 3. So notice I know the hypotenuse. So normally I times to get the hypotenuse, so to undo it, I'm going to divide. So 6 divided by 2 gives me 3. And then to go from the short leg to the long leg, I times by the square root of 3. So this side would just be 3 times the square root of 3. You can ignore those, just change those to x and y. So x is 3 square root of 3, and y is 3. And that's the end of the first page. Please move on to the next video if you'd like to see more.